Good afternoon, all. Welcome to the class. I'm sure you are eager to learn some new concepts today. We have already done most of the linked list programming and all important concepts of the linked list we have discussed. Last time we have discussed the concept of circular as well as header list and merge split also. So all those concepts I hope you have practiced, and all those now you can learn and enjoy programming. Once you get familiar with these concepts and when you get involved in this, a passion of programming will get developed and you will start really feeling that this has become a habit. But it's a good habit. Continue with this. Just last few minutes over the linked list. We have discussed linked stack implementation, but linked queue we have not explicitly discussed. Linked or queue using linked list is also simple and not difficult at all, but let me just give some discussions over this also. So by default, queue already is meaning first in, first out. And as we have said, that linked list is also going sequential in nature. So more or less it is first in, first out kind of thing being maintained. Yes, we need to take care of things. In case of a stack, we had a top variable. In case of a queue, we will need front and rear as a pointers. So front and rear as a pointers will be needed. So obviously you can have a node star front and rear to be declared, and they will be maintained throughout the programming for queue. So effectively that means if, let's say, at some point of time my queue had, let's say you have gone insertion like 1, 2, 3, 4, 5. In this order, you have inserted your data. So that at a time should mean my queue will appear to have front to be on the node which is first to be deleted, which is obviously 1, followed by 2, followed by 3, and in this order they were inserted. So at that point of time, my queue will appear like this, and obviously this being null. The only additional change being now you have a rear pointer also. So in a normal linked list, you have only the start, which is equivalent to your front node, etc. But here the rear means at end also. So otherwise also you know. So in linked list, you didn't have a last pointer, but here rear pointer is available. Why? Insertion is always at the rear end. And if you have to insert at the rear end, you need a rear pointer, and insertion in queue effectively to be done at rear end, first thing. Secondly, it must be done in order of one time. So you have this available. Maybe you want to insert 6. So you will have this done and via this, and then rear will shift here. So this is how your insertion will happen. So insertion is easy, not a difficult at all. So you can definitely have your maybe void star insert or node star insert queue, insert into queue. But obviously now you will need your rear end to change. So you will need rear to be passed as a double star because rear link will change. And rest everything is simple, and new malloc and linking to be done. So your rear variable is existing as a pointer. Alternatively, you can have node star to be returned, and then accordingly also you can have. And here your rear changed rear will be returned. That you can think, but I will prefer this solution. Why? We will just understand. So both can be okay, but you can definitely do via this also. And then rest function without this and this change rear to be returned. So insertion will mean insertion at, so effectively insertion in queue will always mean insert after rear, and insert after rear pointer. Once pointer is available, then you can easily do this in order of one time. Insert after in a linked list is already discussed. In a linked list, if a node pointer is available, insertion is one time. And that time also we discussed that how your pointer will reach to the node where we want to insert. This is how it will reach and this is how it will be done. So this becomes simple. So you can write your insert function. Similarly for the delete. Delete means always from the front end. So from the front end itself to be deleted. So at some point of time, if my list has 1, 2, 3, and so, this is my front end. So deletion effectively will always mean that front will change. Front will now reach here. This node value to be returned and then node to be freed. And this one value, if you want to display, etc., whatever you want to do, that you will do, print or whatever, print, etc., whatever you want to do, and node freed, but front will change. So front is changing. That again means the changed front should be returned by your delete function. So maybe you can have void delete q function and obviously double star based front to be used because changed front should be returned. Or alternatively, same thing, you can have node star delete q and via this changed front to be returned. So that can be another way of doing. So both way you can use any one. Now, 90% times, no issues. Okay. Special situations. You need to think, will there be a special situation? And in this case, yes. Why? What is initially your front and rear? Obviously, you have to initialize. So maybe you will say front equal to null and rear also both to be null. So that will be the starting condition. Perfect, no issues, will work clearly. Now, just think initially Q is this, so initially empty. First time insertion, what will happen? First time insertion, when you do, your front is null, means pointing nowhere. Rear is also null, nowhere pointing. You will try to insert will mean, yes, you will write condition if rear equal to null. The insertion means initially list is empty. So new data red, let's say you have red 1. This you will obviously make null. And then you will bring rear here. So this rear initially was null. You created a malloc, read the data, made this link always null, and rear is here. Next time, if you read another 2, it will be linked further and you can always do. But at this point, do you have to do something more? And the answer is yes. Why? Just see where is front. Front is null. So if you have done first time insertion, at that time front was null, you have to initially bring your front also here. So that becomes a special situation. And you have to handle that. That indirectly means in insert itself, front also can change. Rear obviously changes. Always, because in case of an insertion, rear will definitely change. So rear needs to be returned. But now front also being changed. So in insert itself, star front also might be needed to be used along with star rear. Whatever syntax you have. So that's why I said that I will prefer this methodology so that uniformly you do same thing for both pointers. And in case of insert Q. What else you need? All that, but not only rear changes, front can also change. And similarly, you can think of the empty situation and the last node being deleted. But before that, when the queue will become full, effectively it becomes full never until unless malloc fails. And when malloc fails, we know the new or malloc statement will return null. So that will be the only condition for the full that we can always check. Then going further, and similarly for the delete queue, for the delete operation, there is going to be a special condition. Say if the queue is empty, obviously front is null. You will say, yes, front is null. So delete queue, not a problem. It's an empty. You can easily handle that. No special condition, but you have to just write the code properly. But imagine you are having, let's say, 3 nodes, say 1, 2, 3. Obviously meaning that front is on this node and 3 was the last being inserted. So here you have the rear node. Now you, let's say, deleted once. Deleted once means this node becomes a free, front comes here. Perfect, not an issue. Again delete. First time you have deleted, you deleted second. 2 freed, 2 returned, printed also. Front comes to this node. Again delete. Perfect again. 3 deleted, node freed, and front will be made as null. You will make front equal to null because last node has been deleted. Perfect. But what about rear now? Rear is pointing to a node which has been freed. We should not do that. This, in fact, if rear is pointing to a node which is freed, that is a dangerous situation. And such situation is actually, or such a pointer is actually called a special name. Such pointer is called as dangling reference. So dangling reference is a special word used in programming or via pointers, that whenever you have a pointer which was initially maybe valid, etc., but later because of certain reasons, it points to a location which is no more available for your program, this pointer becomes a dangling reference. We must not have such pointers in this. And otherwise also my insertion will fail after this if I am not handling this. So in case of a delete, my rear also to be made null. If you have deleted the last node, so effectively last node deleted, I'll say last node deleted, not only the front will change, rear also will change. So now I will say that for the same reasons, I will have a delete queue operation, obviously to have front being passed with a double star, always needed, but rear also might be needing a change in some situations, special case. Hence, you need both to be updated and returned. So via node star, only one of them you could return, not both. Hence, it can be a simple way that uniformly you do for the both and rest you are correct. But of course, via node star, if you are returning front, then you can have a front as a call by value, rear as a call by reference as per your choice. So you can implement this. So having said that, I will say just you can try this as a homework. So this you will, at the last, I will write again the homework, but this will be your practice, implement your linked queue also. So more or less, it becomes even simpler than a normal linked list, because in linked list, you didn't have the last pointer. You were permitted to have insertion and deletion in between via having position or after, etc. But now it is fixed. Only deletion from the front end, insertion at the rear end. Things become simple and handle special cases very. So having said that, linked list is over. Now we proceed further and talk of some more new concepts which are going to be very useful for this. Till now, what we have used was either my storage could be an array or could be a linked list. But both of these store the data in primary memory. But primary memory is a volatile memory. Volatile means what? As soon as you switch off the machine or computer, the data will be lost. It will not be stored permanently. Now imagine that you have, let's say, first year result being prepared via a program. So all subject marks have been fed, and your all subjects internal marks and external marks, all those are fed. Then accordingly your total is calculated, subjects grades calculated, and then your SGPA also calculated. Say first semester result I am talking of. And unfortunately some of you could have, or some of the students could have a reappear also, so that also calculated. Now all this has been stored, let's say, in some array or in a linked list. Result is ready. But before I could just print this, or before I could just, or even if I print it, after that I switch off the computer or power traps. So maybe I have a server, but because light went in the night, the machine got switched off. All data lost. Your result is lost. Yes, those students who had a reappear, they will be happy that a reappear lost. But those who had good SGPA, they might not be happy. Or in that case, that means anytime computer would be switched off, whenever I need first year, should I again feed the data and every time do calculation? Obviously not. So I wanted my result to be stored permanently. My all marks, whichever I have entered, I want to be permanently stored. Hence, my array or linked list might not be the choice. For permanent storage, we use files. So we have the file handling to be discussed today, and we are going to see how to use files during programming, through programming. Of course, one reason why I need files, I have understood as a permanent output. So effectively output in files to be stored so that your data remains permanent. But it's not the only reason. I say sometimes I will prefer input also from files. Why? Even if not permanent needed, but sometimes it could be useful. For example, let's say you had 1,000 students in school. Let's say you have school result. 5 subjects each student has. So total, I have a sheet, a matrix, let's say, of student from roll number 1 to 5,000 and 5 subjects. Subject 1, subject 2, subject 3, 4, 5. And based on that, let's say I want to find out each student's total, I want to find out each student's percentage, etc., etc. But effectively, 1 to 1,000. So effectively, I have 1,000 students into 5, this much data to be inputted, to be read, to be input. Now imagine, say you wrote a program, your program worked and wrong results came. Because of some programming error, quite possible, you write initially program and you got wrong result. You will correct your program. Yes, you will correct, find the mistake. For example, you forgot to initialize sum to 0. So you will get some random total for each student. You corrected the program, re-execute. Now, when you re-execute, again input of 5,000 students or 5,000 values to be fed. Again, you have to type. If unfortunately program became again wrong, obviously you have to again do all that. So retyping every time. I can avoid retyping by storing the data into an input file and then use input file every time. So whatever data I needed for these 1000 into 5, instead of storing into an array only, I will store all this data in an input file first time, and after that, from that file, I can always use. So first time I will store here, and subsequently I need not type again and again. So this is what is the advantage of having something as the corresponding input file also to be used. So we have strong reasons to have input as well as output files. So let's now see how to generate and use files by programming. So from the programming angle, let's start doing that. So for programming, effectively, I need files, one file as an output file. Effectively means to store the results of the program generated by your program. And second, I might use an input file, which means the data needed by the program by your program will be read from the file, not from keyboard, instead of keyboard. So these are the two kind of files. And you might be willing to use both kind of these. So we will do programming for both of these one by one. Both have similar programming. First thing is, of course, hash include stdio.h to be done. stdio.h, this header file is sufficient to handle all file-related commands, functions to be supported. So all file-related operations which we are going to use are supported via stdio.h. Then we have to declare a variable of type file pointer. For example, if I write this, file is in caps, note down. So first time we are using a data type in caps. Like earlier we have written int, char, float, whatever, all were in smalls. And file is again a reserve word, is a new data type. So fp point out is a file pointer. Star always means a pointer. So, and file means a file pointer. And outward I have used, so this name I have used as an output file pointer. But of course, you have a name choice as per you want to give. You can give it as fp1, fp2, or you could say outfile1, outfile2, or whatever name you want to give. It's just a variable name. So variable name, meaningful variable name to be used. Rest is your choice, whatever you can give. So when you write this effectively in C programming, this effectively means file means you open a stream. So whether you say file or stream, more or less it is one the same thing. More details of stream word, etc. you will understand in OS in more detail, but we normally call it as a stream also. When you write this, effectively via this, you create a buffer area. And why do you need a buffer area? I'll explain. So by declaring an FP point, your FP out is pointer to the buffer area. And why buffer area is being discussed, although at your point, not much of a difference. But what I say is your program always works with the primary memory or with the RAM only. But your files are always stored on the secondary memory. So any kind of a file you are using will be actually in the secondary memory. Your program never works on a secondary memory directly. Hence, within the RAM, you have a big RAM available and your secondary memory is much more bigger. So you will have here some buffer area declared for a particular file, and your synchronization between that particular file versus buffer area will be taken care by OS. So operating system will be there to handle all this synchronization and use of buffer area. But for all programming purposes, you will only work via buffer area. So your FP out will be effectively working via this. So you will use FP out to work over this buffer area. How buffer area will synchronize and all that OS takes care, I need not bother. But you can safely assume that you are directly working on the file. So not a big issue. So FP byte is my file related point. Now, for file handling, mainly 3 steps. First step, always open a file. Third step will be always close the file. And in between, you can have a processing on the file. And processing on the file will mean reading or writing or whatever you want to do. One time, twice, thrice, whatever number of time you want to do, you can repeat anytime. Opening of the file will be once. This will be also once. Whenever any processing is to be done, the file must be open. After you close, you can't do the processing. So this will be the process. How will you do? For example, I have declared file star FP out. Maybe in main I have declared. If you declare in main, it's a local variable within the main. If you declare global, then you can use it global also as per your requirement. First thing, you will say open a file. So for opening a file, the command is fp out equal to fopen file name. For example, I say output.txt and wt. See here, something important to see is this is your file name used by OS. So your browser or file manager, you will see ultimately this file to be named as output.txt. WT, here W means write and T means text. So one kind of a file is a text file. Other kind of a file is called as a binary file. For that, B will be used. That we will see in the next class. But by default, WT is equivalent to saying W also. Default files are always text files. So if you don't specify T, still it will mean a text file will be used. If you want to use binary, the B will be compulsory. W means write file. W means write into file. So if you want to write something to a file, you will open it in write mode. Effectively, it means your output files will always be opened in write mode. What does this mean? There will be a new file created with the name output.txt. Even if the file existed, it will be overwritten or previous contents will be lost and a new file will get generated. Where? Always into current folder. By default, it will be always stored into current folder. Say, if you are doing a programming into C:/dev/cpp/1221001, let's say like this, and here you have your program pg1.c. So that means you are into this current folder. This is your current folder. in your browser or in your file manager, this file output.txt will get created in the current folder. So fpout is the first command which we will use. Of course, file will be created only once we close or give the fclose command. Before that, it will not be permanently visible. That's the purpose of fclose command. But yes, I have done fpopen. So fopen command I used equal to, fpout equal to fopen we have written. And file name we have given and maybe w or wt written. So output.txt in double quotes because this becomes a constant fixed name. Immediately next statement, we must check whether file was correctly opened or not. So if fopen fails, null will be returned, and then I could say print or do some action, whatever you want to do, that file could not be opened. File opening error. And whatever action you want to take, whether you want to terminate or whatever you want to do, that you will do. With output files, normally this problem will not come because file will be default created, but maybe hard disk was full and you have no space to create a file, so this could happen. This will be more frequent in the input files, but for the time being also it can. So we must check normally this, and then maybe you want to say exit or whatever you want to do, you could do that to symbolically tell that file could not be opened, we can't proceed further. Otherwise, coming here means file has been opened clear. So file has been opened and now it can be used. I want to write into file. So W means write into file. So whatever your program generates output, whatever output is generated, if you want this output to be stored not on a screen, it can go to an output file. So effectively means output generated and not on a screen, you want to the file. Then you will use output file. For example, if my program has generated the result of students, so I could say, okay, roll number this, result this. So you could store your all data, roll number, results, marks, result, all this data. So you could have in the output file. And that file will remain permanently stored and you could use it. Remember, this output file is always a text file and can be opened in Notepad or DevCpp or Word also or anywhere. Because it's a text file. So text file means even in Notepad it can be opened. So you can see this file through any other editor. See through editor. You can read this file through editor also. So whatever file you have created, it's not that only via programming you can use, you can always read it. fpout done. Now I have to write something into file. So earlier for writing on a screen, you used printf. Now instead of a printf, you will use fprintf. That's it. And fprintf is same as a printf. Earlier you used to write a printf. Printf you used to write, let's say, for example, hello. You used to write printf like this. If you use fprintf, it will become fprintf, file pointer name to be written, whichever file pointer, and then whatever message you want to write. This file name only used here. Nowhere else in programming you will use this. Never you will use this word again. Everywhere you will use fpout. So what does this mean? It means when you did fopen, you got a buffer area, then via buffer area, effectively a file which is named as output.txt has been opened, which is initially empty, and your cursor is ready to write here something. Like on the screen, you have a screen ready and ready to write something. Printf means hello written on the screen. Fprintf means hello written here, and immediately the cursor is on the next position. So if you have written hello, this is written until your FP pointer doesn't change. FP out is not changing. FP out is somewhere in the buffer area. So internal pointer is internal cursor is somewhere used, and that cursor was initially here. Now it has shifted. That cursor will tell where the data will be written. So sequential writing only will happen. Only sequential writing. All data will be always written in the order of place, like on the screen. You can't write in between. Once you have written, just go next line, next character, anything like that. Here also, if you write /n, next character, etc. For example, instead of this, had you written hello/n, hello/n will mean after writing hello in the file, cursor will come to the next line. But if you have written only hello, cursor is here. Say after this you write another printf statement and fprintf. Say if you want to write, let's say, a and b values. I have variable a. Say I have int a equal to 10, b equal to 20. And I want to write this data on the screen. For that, you could have written printf statement. If I wanted to write printf for %d, a, b, then 10 and 20 is displayed on the screen. I want to write the same thing into file. I will write fp out. That's it. %d means value of a and b to be written on screen or onto the file. Cursor is here. So a's value 10 will be written. Cursor will accordingly shift here. B's values to be written. There is no blank in between. Immediately 20 will be written and cursor comes here. So effectively now what you have got is HELLO 1020 and cursor here. This is your file being created for the time being, not fully ready till we close it. So this is cursor is here. If I write something more, it will write sequentially here. Then let's say you write fclose. So fclose command is again simple. You have to simply tell the pointer name. Fclose, fp out. Fp out will mean this file now ready for OS to be used as output.txt. So now this file will be physically visible. You can open and use anywhere. Copy, paste, take to the pen drive, print it, display, notepad, whatever. So this file will have contents hello 1020. That's it. This is a simple fp out or fprint out commands. So any output file to be created effectively means instead of a printf, you can use fprintf. Printf meant on-screen output to come. You can use fprintf. That's it. Simple. So nothing else to be learned. All programming remaining same. Whatever you want to do, can do. For example, let's say I want to create a file. I say, I want a program so that a lot of data is being read and I need not repeat. So I want to create a file which has maybe 5,000, 10,000 integers, and later I want to use those. So I say, read from the user n, and then read all n values. Yeah, total n values, n integers from user. And generate an output file which has value of n as the first value n, for example, if you say 5,000, then 5,000 should be stored at the start and followed by all n values or all n integer values. I want to write a program for this. Meaning, for example, if I say n is 8, so if my n is 8, I want an output file to be created, which will initially have 8 here and followed by some space to have next integer values. For example, the values which I gave is 25 minus 307, 768, 2579, value 5, 1, 2, 3, 4, 5, 77, minus 2, 6, 7, and maybe 206789. 20789. 1, 2, 3, 4, 5, 6, 7, 8. So I want my output file to have contents like this. This is a blank in between. 768, 2579, 577, minus 2, 20789. And this will become my output.txt. Let's see. Remember, I want a blank in between. Earlier, you just see we have no blank in between. So if I want to print a blank, like on screen, in percentage %d, after that I have to use blank. So the same process now to be repeated. How to do this? Try this. I'm giving you a few minutes. You can do this. You can pause this video, see this, and I'm sure you will be able to write. You have to just read your n. After reading your n, you have to do that as a fprintf. After that, you have to read n values, and whichever values you are reading, you have to do fprintf for that. And finally, close your file. So try that. I'm giving you a few seconds pause. Once you are ready, you can resume the video. So I resume and showing this. So in main or wherever you are using, you have declared your file star pointer, capital file. You have done fp out. fp out equal to f open you have done, I assume, not an issue at all. If fp out equal to also you have done, that also I am not writing again. Whatever conditions you wanted to write, you have written. Once done this, now, first say what I said. I ask the user enter the value of n. So if you want to give a message, maybe you could say printf and ask the user enter the value of n. Printf is okay because from the user I want to read, this is not which message I want to write in the file. Whatever I want to write in the file, that will need fprintf. You will do scanf. Now, so n is ready. My question said that this n also to be stored into the starting position. In my output file, value of n also should be stored. So the first statement I will write is fprintf. If you wanted to write the n on the screen, you will simply write %d. One blank in between you will write so that the value 8 is separated with the next value 23, etc. So one blank in between. This was a printf statement. If you want to use fprintf, the file pointer will be written. Done. So red value and this. Now what? You need a loop. For I equal to 1, I less than equal to n, I plus plus. What you will do? First, you will do the scanf. From the user, you will read the value. Scanf statement %d, no blank, etc. we write. Remember, in scanf, any extra symbol before or after %d can be dangerous. With integer, it doesn't create problem. With other data types, it can. So simplest is don't put any special symbol or blank or slash and etc. anywhere in scanf. Scanf simply %c, %d, no extra symbols. N red is not n. I'll say some new variable. Let's say val. So I have declared some integer variable and that val is being read. So first time I gave 23, val gets 23. I want it to be written in the file. If you have to print it in screen, you will say printf, you will say %d space printed and val being listed on the screen. You want it to write to file. The only change being it will become fprintf, fp out, and this, that's it. So just this extra and this word alphabet f extra. Rest everything is same. And a comma, of course. Done. And that's it. So initially you gave at 8, your file output.txt is created, is being written. You wrote 8 and cursor is on the one space before and then X because you have written a blank here. So one blank here, cursor is here. Now you read let's say 23. So you may be pressed enter or whatever. Now you have given 23. 23 will be written here. You have also written a blank here. So after this 23, one blank and cursor comes here. You gave after this minus 307. So it will write minus 307. Cursor keeps on shifting. And after that, you have written one blank. So one blank is also here. Blank we normally show like this. So a blank is appearing in between. So this is a symbol to show blank. In the books or somewhere you can use this symbol to remember this. So that is being written, 307 written. After that, let's say you type 768. So you will get 768 and then a blank and next character and so on. So this file is getting created. N values will be written. Finally, you say F close, FP out. The file is ready. By this, all this data will be ready, buffer area freed, and now your file is ready, and this file will be available on the hard disk in the current folder. So fclose will ensure everything has been correctly written. Ready. So you can use this. Why we are creating? For example, n could be 5,000. I have typed 5,000 values once, and then I can reuse it any state. For example, I wanted to find average of these n numbers. But n was very big. I need not type again and again. Sometimes I wanted find average. Sometimes I wanted highest. Sometimes I wanted minimum. I need not type again and again, and n could be big. So now we will do program 2. Second program. I want to find average of n numbers where data is in files. So effectively, I mean find average of n numbers where value of n is in the input file at the start of the input file and all n values are also in the input file. That is, let's say integer values are in the input file. And you want to find the average, and find average effectively I want to say, let's say display on the screen. So effectively this means now my program needs input from the file. Input comes from the file to the program and average is displayed as output. Can be on screen. If I want in file, again, I can have a separate file. I can have multiple files, but now I want this to be an input file. So if I have to use input file, again, fopen command will remain same. File name will remain whatever is actually, but I will say read mode, RT, or you can also write simply R because the T is default. So that is the only change. Instead of W, we will write R. Similarly, instead of fprintf, I will use fscanf. Instead of scanf, now everything will become in terms of fscanf. What does that mean? Let's have a quickly an understanding. In main, your file variable will be declared. For better naming or for readability viewpoint, I will name it as an fpin, file pointer for an input file. fp, file pointer for an input file. First command, open. So fpin to be equal to fopen. File name, the file name by which it is stored into the hard disk. So if I have named that file as output.txt, same file name is existing now. So by the last program, whatever we created, I'm going to use that. And now I will open it in read mode. We have already created. This file must exist into the current folder. Otherwise, it will not be opened. So my fopen will fail. If I want this file to be used, this must be present. So my next statement will be obviously fpin equal to null. Then it is an error, and accordingly, I can't proceed and whatever you want to do. So this part you will immediately check. Once this is done, assuming file exists, earlier, if you have to do this program without file, so you wanted n to be read. Earlier, you used to write scanf. How did you use to write scanf? %d %n. This was reading from the screen or from the keyboard. Now you want to read it from the file. So syntax changes only this much. That's it. fpin and fscanf. This file pointer is the same as what we have named earlier. That's it. So with whatever file name we have opened, that can be used. fscanf. So it means in the file it will go output.txt file being read. Being read means always your internal cursor is at the first position. Here you have written 8, then you have written a blank. After blank you have a 23. After blank you have a -307 and so and so. So by this 8 read and cursor reaches to next after 8. Why 8 read? Because after 8 there was no digit. Now, if you forgot to put a blank in between, the value will appear as 823. So it will read n as 823. So the way you read from the keyboard till you don't press blank, it is read as a common integer. So you have to be careful to put a blank, especially for the integers. So that is now done. Now what you want? You want to read data from the file. So you need a loop less than equal to n. I++, and then you want to read the data. If you wanted to read from the file from the keyboard, you will write a scanf %d %val. That was a normal scanf. You want to use it from file reading, fscanf, fpin, and that's it. Data ready. Say you want now this to be summed up. So you will have a sum variable, sum equal to sum plus val. Immediately it will recall me that I need a sum to be initialized as a 0 along with the declaration, so that you will ensure, and repeat the process. So every time I will read a new value into variable val and add it. Again, reading is also sequential automatically. Always sequential by default. Always. Until unless we have something special, some special commands used. Otherwise, by default, after reading 8, my cursor is here. You wanted to read val. Blank is ignored to read integer. So it will go to 2. 2 read. After 2, there is another digit. So it says integer is still continued. 23. Now a blank comes. So it becomes a 23 as a val variable. 23 read, sum added, again command repeated, again val to be read. Blank ignored, cursor goes to next, minus. So minus means a negative number starting, 3 coming, accepted, 0 coming, again means it becomes minus 30 probably, 7 coming, now it becomes minus 307. Internally, somebody is taking care to do all this, and now a blank comes. So it says, yes, the data is ready. So your reading command has ensured that now it is read as a minus 307 and val variable gets minus 307. Same process repeated, all values will be read, and after that you wanted to find some average, so you could say average equal to sum slash n, and you wanted to print percentage d, percentage f, whatever you want to do, that you could get your output printed. So this becomes your input file based programming. And of course, finally, you will close your file. Fclose, fp in. So having said that, this was use of input file. Effectively mean that fscanf used instead of scanf, wherever you need it from the file. If you wanted to read something from user, you will use scanf. If you wanted to use from file, you will use fscanf. So now I'll wind up and tell you that last point to be discussed here is that file name need not be fixed. We have fixed, but can be read from the user also. If you want a file name not to be permanently fixed, for example, let user tell what file name you want to read, it can be read from the user also. Ultimately, any name means it's a string or character array. So you can declare a character variable, character array variable, and use that. What does that mean? Let's say I will say character file name, let's say 50 or whatever length you want to give. Then you will say, fine, I will ask the user, tell the file name you want to read or write. So you can ask the user, tell the file name. Now you have to read from the user the file name. How to read? Percentage %s or get s and the file name, comma, file name. Or you can use get s, that also does the same work. Whatever you have been doing. From the user, you ask the file name. Now, in your file opening or fp in or fp out, you will say f open, no double quotes, file name, variable name, comma, let's say read or read text, whatever. No double quotes. Because a double quote means it becomes a constant name. You don't want a constant name, it's a variable. File name is a variable. So file name will mean no double quotes. If you say file name to be abc.txt, a file attempt will be done to read abc.txt. If you say output.txt, xyz.c, for example, if you say xyz.c, the file will be read or file will be attempted to open a file which is named as xyz.c. It's not that you will write always txt. You can write .c, .abc, maybe you can write .mmp and say some name you give. Your choice. Any extension you can give. You have to open it by a notepad, whatever you want to do, but you can give any extension which you want. But for our files, normally we use either .txt or maybe sometimes we write .dat and whatever to show that it's a data file. So .dat also used sometimes in various programs, but it's your choice. Your choice. You have to decide. So this way you can do file name to be read, because this is the only place file name will be referred. After this, never referred again. So whatever you read, will be opened, linking or that synchronization between OS versus buffer area maintained and then over. So having said that, let's wind up. I'm giving you the homework for today's discussions now. Let me just submit you what we have to practice. So I'll give you today's homework. First thing, of course, I have already said implement linked stack, linked queue, sorry. So linked queue will effectively mean your insert queue, delete queue, those operations to be implemented and test via various calls. Number 2, I'll say generate an output file storing capital A to Z, A, B, C, and so up to Z in the file. All in same line, without space, etc. So effectively, no input to be read from the user, output to be generated. Third, improve above to store A to Z in separate lines. So effectively, I mean that my output file should have A in one line, B in another line, C in another line. So don't write simply printf1 A to Z. You will need a loop 26 times to repeat, and similarly here also. Simple. Fourth, I will say, assume that you have, say, some string to be read from the user. Read a string from the user. For example, user says HELLO. Store its a capitalized string into an output file. In an output file, and output file name to be told by the user. File name also will be told by the user. Meaning what? If you have read HELLO as input in your output file, it should be stored all caps. Whether H was capital or not, but all others, all that in caps. And the file name, maybe I will say, let's say it was a sample.c. This is user told. So if user told sample.c, it should be stored as file name as user.c. Final, last one. I'll say, now assume that you have an input file. What kind of a file? It has initially some n value, and then n different characters or integers, etc., etc. Int, char, or I'll say int or alphabets, blank, or special symbols. Meaning that I have a file something like this. Let's say here I have written 21. It means the total 21 characters will appear here. Maybe I have a blank. Then I have here A. Then I have 7, 8. Then I have a comma. Then I have small z. Then I have 3, 5, dollar, semicolon. Then I have, let's say, M. Then I have capital M. Then I have 3, 4, etc., etc. Then some blank. Then again 5. Then again blank. Then maybe semicolon, semicolon. So 25 different characters are there. 21 different characters after 21. I want output to be generated on screen to tell count of digits after 21 this size out of the in these 21, count of alphabets, count of blanks, and count of symbols, extra symbols, other symbols. So for example, I could say 1 blank, 2 blank, 3 blank. So blank is a 3 digits, 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, 6 digit, 7 digits. Alphabets 1, 2, 3, 4, and so on. If there could be more, for example, 4. Special symbols 1, comma, $2, semicolon 3. After that, another 4, 5, and so on. So if the total values could be more also, so maybe currently we have 5 and then according. So this output to be calculated from the file. This you should be able to do this. But question is from where you will get your input file. So how to have your input file? So answer to this will be simple. For testing your program, either generate your input file through your programming itself. How to have your input file for testing your code, for testing your question 5, which is this is question number 5. Yeah. So solution 1, generate output file through your programming with that name and store that, and then accordingly use that. Solution 2, simple. Go to Notepad and create a file there and type and create the file. Keep some file name. Ask the user the file name as per your data. So you can use any solution. Both will work equally good. So for testing your program, this you should be able to do, I'm sure. Should not have a problem. So you can use any of this. So with this, we are over. Next lecture, we are going to have one more lecture on files. And then we will resume with some more data structure discussions in more detail. Bye-bye. All the best to all of you. Enjoy. Have a good day. Bye-bye.